and welcome back to my online teaching platform, still on derivatives of trigonometric functions. In this video, we shall consider the function y is equal to cos x. Alright, so we are going to use the first principles method to find the derivative of the function y is equal to cos x. Alright, so we know our formula to be dy dx is equal to the limit as the small change, which is h, approaches 0 of f of x plus h minus f of x, all divided by h, the small change in x. So we know our f of x to be the original function, which is the cos x. All right. Now we have to get our f of x plus h because these are the components of the function. So our f of x plus h simply means that you plug in x plus h for x. So we have cos, whenever you see x, you plug in x plus h. So it becomes cos of x plus h. All right. So we can now plug in the various components of the formula. So we have dy dx is equal to the limit as h approaches 0, then our f of x plus h is cos x plus h, then minus f of x, which is the same as the cos x, all divided by h. All right. So let us apply the compound angle identity here. So we have cos x plus h. So let us expand this one first. This will give us, under trigonometry, we treated compound identities or compound angles. So we have it as cos x, cos h, then minus, the sign changes to minus. So it's going to be sine, here will be sine x, sine h. Alright. So we are going to replace cos of x plus h with cos x, cos h minus sine x, sine h. So our dy dx will be equal to the limit as h approaches 0. Then we have cos x, cos h minus sine x, sine h. Then minus the original function, which was, which is the same as the cos x. So original function is cos x. So all over h. All right. So we now have our limit as h approaches 0. We see that we have cos x here. We also have cos x here. So we can group like terms. We have cos x, then cos h minus cos x. Then we bring back the other term, which is minus sine x, sine h, all divided by h. All right. So we can now factorize the common factor out. So we have cos x being common to these two terms. So we are going to get limit limit as h approaches 0. Then you'll be having your cos x right outside, and you get your cos h inside minus 1, open bracket, all divided by, okay, we are left with the other part, which is minus sine x, sine what, h, all divided by h. All right. So we have the limit as h approaches 0. So this identity, so now we can now take our limit. So let us split it before we take the limit. We are going to get our cos x, then we open bracket, we have cos h minus 1 in bracket over h, so the whole of this over h, then minus, we are just splitting it. They all have the same denominator, so we can split the numerator. So we have sine x sine h also over h. All right. So this identity, so we know that, but when you take limit of cos h minus 1 over h as h approaches 0, the answer is always 0. All right. And when you take the limit of sine x, but here let's use the sine h because we are taking a limit with respect to it. So sine h over h as h approaches 0, we are going to get the result to be 1. So you could see that we have cos h minus 1 over h. So you can now take the limit. So when you take the limit of this as h approaches 0, you are going to get it to be, so the whole of this will be 0. And yet we have sine h over h. So that place becomes 1. So we are going to get cos x multiplying 0 minus sine x multiplying 1. All right. So we are going to get it to be cos x times 0 give us 0 minus sine x, because sine x times 1 give us sine x. So this becomes negative sine x. So we conclude that dy dx is equal to negative sine x. So anytime you are differentiating cos x with respect to x, you are going to get your result to be negative sine x. All right. All right. So, but it's not always x. The angle can be in terms of any other variable. So suppose you have derivative of cos theta. So you are going to differentiate it with respect to theta. And this will give you negative sine theta. All right. Thank you for watching. Please do not forget to subscribe to my YouTube channel, Math with Ebefa. In our next video, we shall learn how to differentiate tan x. Thank you.